Welcome back everyone to this lecture on time resampling. We'll usually get financial data that has a date-time index on a smaller time scale. That is something like every row corresponds to every day or every hour. However, it's often a good idea for analysis purposes to aggregate the data based off some sort of frequency, such as doing an aggregation on monthly data or quarterly data. Now you may think that using a group by could solve part of this issue. You would just simply do a group by and then group by every 3 months, and that will give you quarterly data. However, a simple group by statement isn't really smart enough to understand things like business quarters or business year starts, or the fact that a business week starts on Monday instead of Sunday, that sort of thing. Luckily, Pandas has frequency sampling tools built into it to actually help with this sort of problem. To learn about this, we're going to be using a stock market data set of Walmart prices. It's located under the time data folder under the 5-Pandas with time series folder that corresponds to this section of the course. Let's open up a new Jupyter notebook and get started. Okay, here I am at my Jupyter notebook. I've imported the usual suspects here, NumPy, Pandas, and Matplotlib, and we're going to continue by reading in our data. I'm going to show you two methods of reading in the data. One is a little longer and it's a little more customizable. The other one is a little faster. So what we're going to say is df is equal to pd.readcsv, and then we'll pass in the actual file path. Depending on where you are, your file path may be different, but I'm just going to say time data Walmart stock CSV. This matches the notes, and I will read this in. And if I check out the head of my data frame, I can see I have a couple of columns here, and note here that there's a date column, and the date column is what I actually want to be the index. So if I take a look at the date column, or actually if we take a look at the entire data frame with just df.info, I can see the date column is actually says non-null object, which indicates that this is still just a string. It's not a datetime object. So we need to convert this to a datetime object. And that's actually quite simple with Pandas. There's different ways of doing this, but the simplest way is to say df date and set it equal to pd, and there's a special toDateTime function, and then you can pass in an entire series such as the original date, and what this is going to do is you're passing in the original series of the date, which is just strings, and pd2datetime is going to reformat it to be a datetime object, and then it'll set that to dfDate. Now luckily for us, this string is already in the standard notation. It expects a year dash a month dash a day. But in case you have a different notation for your specific date string, what you can do is under pd2datetime, if you do Shift Tab here, you'll notice there's a format argument. And this format argument basically takes in a string that essentially tells Pandas what format it's in. So if you scroll down here, there's an example of what that string would look like. So we'll keep scrolling down until format. So this is just a string telling you what format to expect it in. So in this case, this sort of string says, okay, expect a day, then a forward slash, then a month, then a forward slash, then a year. And there's actually different types of special characters that start with those percent signs that tells Pandas what kind of day or what kind of month to expect. So for instance, the difference between percent sign lowercase y are the last 2 digits of a year, percent sign uppercase y, those are the full 4 digits of a year, etc. And you can look this up in the Pandas documentation or in the provided notebooks for what these key terms are, this percent sign key term. Luckily for us, we don't really need to provide that information because it's already in the standard format. So we're just going to hit enter here and then check out the head of our data frame. Notice it looks the same, but when I say .info, I can see that it's now a datetime object. So we have that ready to go. Now, another way you could do this possibly is instead of saying pd2datetime and then pass in the series, you could also just apply pd2datetime to every element in the series. So do something like date apply and then call pd.toDateTime. I've seen that as well. And then you just set something like this. So it's really up to you. These perform the exact same function. I would recommend doing it this way with pd2datetime and then passing the series. To me, that's a little more readable, but either way should be fine. And let me delete everything in the cell and then clear it out. Okay, so we have our new date column, and it's now no longer just a string, but it's actually a datetime object, which means we should be able to set it as the index. So I can say df.setIndex and then pass in date. I also want to call this in place be true. So if I take a look at my data frame, I can see I have now the date time index and then the various columns. So that's kind of the longer, more manual way, but it gives you a lot more control, especially with this PD2 date time. Lets you have full control over whatever format the date's in. If you actually want to read in the date as an index since the very beginning, you could have just up here specified pd.readcsv, and you can also add in an argument index underscore column and specify that the index column is the date. However, keep in mind that this will still read it in as a string, and you will have to reformat the actual index to be a datetime object. Now, an additional thing to note here is that Pandas actually comes with another parameter you can add into read CSV that will actually do this parsing of dates for you. And that's going to be parse underscore dates, and you can set it to true. And what this does is if you provide an index argument, such as set the date column to be the index location, parse dates set to true will automatically try its best to parse this column as a datetime object. So let's try this out. We'll reread our data frame, and then if I check out the index, it is now a datetime index. So this is the faster way. It's not as controllable as the way we just showed with the step-by-step, but if your data is already in expected format, this will save you a lot of time. You just pass in your data, set the column date, and then say parse dates equal to true. There's other things you can do with parse dates, such as adding in an actual list of columns to try to parse, things of that nature. You can always check out the documentation for more details. So we'll just stick it with this way, index column parse dates equal to true, and I'm going to scroll all the way down here, come back to our DF, hit enter, and everything's the same. So let's continue along and start talking about time resampling. So to do any sort of time resampling, we're going to need a date time index. So if we scroll down here all the way to this next empty cell, again, just as a reminder, we have a date time index. What I can then do is off this data frame, say resample, and then provide what's known as a rule. And the rule is just indicating how do you actually want to resample this data. So for instance, I can say rule is equal to the letter A, and then if I run this, it'll say, okay, you have date time index resampler. And this is essentially acting as a group by method specific to time series data, that is date time objects. And there's keywords for every kind of possible series offset that you could think of. So I'm going to bring in a little table that's available to you in the corresponding notes for this lecture. So let me bring it in from my right-hand side of the screen. So there's a little table here. This is available to you in your notes. And there's an alias corresponding to every single type of description. You can see there's dozens here that are very, very useful. We're just using A, which is year-end frequency. So we can expect the last day of the year as our resampling. So we'll bring this aside now. And you'll notice here you have a date time index resampler saying, okay, it's resampling based on the end of the year, but any sort of resampling is going to need an aggregate method to actually give some sort of result, which means essentially operating like a group by, you can then say something like mean. And now what this will do is it gives you the mean value based off the resampling of the end of year. So everything before 2012, 12/31 had a mean of 67. Everything between 2012, 12/31 and 2013, 12/31, aka the end of year, had a mean of 75, etc. And you can just keep doing this for a different resampling. So I can do another resampling rule. Let's try doing a quarterly one. So you would look up in that table, and then you would realize it's Q. Some of them have obvious letters, some of them don't. And then you would get now quarterly resampling. So here we have quarterly resampling. And then you can also do business quarter end frequencies. So you can do something like BQ for business quarters and grab the means based off your business quarters, which may slightly end the dates if it's end of quarters a Friday, that sort of thing, instead of just a random Saturday. So that's important to know as far as the different rules that you can apply. And you can actually also apply your own custom functions to any of these resamples, just as you could with any group by method. So let me show you what I mean by that. I'll scroll down here. If I say resample, and I give it the rule to be, let's just do end of year again, and I ask for the max, that's going to return the max price per that year, basically ending it on the last day of the year. But let's say I actually wanted to return the first instance of the period, regardless of any sampling rate. What I can then do is instead of max, I'll define my own function. Or you can even do this as a lambda expression, depending on the complexity of it. I'll create a function called first day, and it takes in some entry. In this case, we kind of expect the series here, and then it's just going to return entry 0. So indexing the very first entry off of this. So this is called first day. And instead of doing max here, once I've ran this and defined the first day, I can say, okay, take my data frame, resample it based off the year end, and then instead of calling max or mean or standard deviation, that sort of thing, I will just apply my own kind of time series function, which is called first day. And note, I'm not calling it, I'm just passing it in. So I'm not executing it with parentheses, I'm just passing it in like this. So now what this does is it returns the very first sample or entry for this particular time period. Okay, so let's show you what you could do with visualization with these resamplings. It's not super common to have to do your own applications this way as far as doing a .apply, because most of the things you want are already built in, but just keep that in mind, it is possible. Moving along to the visualization, just want to show you kind of two quick visualizations illustrating why you would want to do something like this. Let's say you actually wanted the kind of yearly end mean. How would you do that? Well, you could ask for the close column, and then you can call resample not just off a data frame, but actually off the series or the column itself. And then we'll resample with A, and then I'm going to ask for the mean of the closing price, and then I'm just going to do a bar plot. So we'll say plot kind is equal to bar. So you can see our output here gives us a nice little bar plot indicating the mean or average for those years themselves. And we can kind of edit this to resample, for instance, by the month. So let's say M here. And if I run this, now I get this monthly kind of average. So you can see there's a big dip in sales there. Now formatting wise, you're going to use all your matplotlib skills to reformat this. But we could also do something like just set a bigger fig size. So I'll set fig size 16,6. I don't know, that may be quite large, but okay, here we go. And it's kind of a nice little figure here. We can see the dip in monthly sales, etc. So that's the kind of thing you would be using for resampling. Now note that I'm using a bar plot because technically these are all categorical points. This is not a continuous value because the dates are actually holding some sort of aggregate method on them. So keep that in mind. This is not a continuous plot. This is a bar plot. So it's a little different than something like a histogram. Okay, thanks everyone, and I'll see you at the next lecture.